So we previously ended talking about the particle zoo, or we just kind of introduced the concept of the particle zoo. Now, just like when we talk about anything in biology, and we start to classify things by like phylum, kingdom, and all of that stuff, we're going to do the same thing with particles, just because we can't just have all these gaggle of particles and no sense of order. So the first thing is we're going to have every single particle, and it's going to fall into either two categories. It's going to fall into the lepton category or the hadron, and then the hadron can be broken down a little bit further. Now, I don't even remember where I took this diagram from, but I really don't like the word fundamental there, so I'm just going to scratch that out. I probably should have taken this out of my notes a while ago, and I probably said I'd do it every year and have forgotten to. But pretty much every single particle we're going to categorize as lepton or hadron, and then we'll break down the hadrons. So leptons, it comes from the Greek word leptos, means thin or small. So these are the smallest of our known particles. To date, we only know of 6 of them and their respective antiparticles. Now the thing is, leptons, they do not interact by the strong nuclear force, so that means they're not affected by it. The 6 leptons that we know of to date are the electron neutrino. So the neutrino that we've dealt with in beta decay, that is the electron neutrino. We have the muon neutrino, the tauon, and the tauon neutrino, and of course their respective antiparticles. So we really know about 12 leptons. So leptons, and this is why I scratched out that word fundamental particle, leptons are what we would call in physics, these are considered fundamental particles. They are not made up of anything else. Once you get to that lepton, that's it. Another thing I'm going to add in here, this will be explained a bit more later, but leptons are special in that they do not have any quarks. But we'll talk more about that later. In Alberta, we call these fundamental particles for leptons. Another terminology that people may use is they may say that they're elementary particles. Whatever terminology you use in your curriculum, your jurisdiction, stick with that. I'm just kind of sticking to what I know for Alberta. So that covers leptons. The hadrons, this comes from the Greek word hadros. So these are thick, these are larger particles. So they do interact via that strong nuclear force, which just means they're affected by it. And what we can do is we can categorize these further into baryons and mesons. And my IB people will learn this, but if you're not an IB, a baryon just means it's made up of 3 quarks. A meson means it's made up of a quark and an antiquark. We'll talk about quarks a little bit later. So protons and neutrons, since they do interact via the strong nuclear force, that is what holds them together in the nucleus, they are considered hadrons. In fact, they're actually considered baryons. But again, talk about that later. You may, for those of you that do a little bit more physics later on at the post-secondary level, and especially if you do something like quantum mechanics, one of the properties you'll most likely encounter when you're talking in particle physics is you'll be talking about the particle's spin. It's essentially related to the object's angular momentum, which in itself is sort of like the rotational analog of linear momentum. So the spin itself, it can either be an integer or it can be what we call a half-integer spin. And then this number is multiplied by this factor of h over 2 pi. So particles that have this half-integer spin, these are what are called bosons. Particles that have this integer spin, these are known as fermions. But for Alberta and IB, this is just extra info. You actually do not need to know this for our course. I just put it in there just to kind of like further explain it, just as a little bit of extra information. And then I've also just taken this from the Pearson textbook for Physics 2030. So these are just showing different particles, the symbol, and their mass. Again, the only ones that we really need to know about strictly in Alberta physics are the electron and the electron neutrino. And then for IB, we're going to talk about the muon neutrino, the tauon, and the tauon neutrino. These other particles, if we need to talk about them, we will talk about them, but there's nothing like special that you need to know about them. And then one last comment, you'll notice here the mass. You'll notice it's got some really funny units. It's not in kilograms, it's not in atomic mass units. We have this MeV per c squared. That we're going to explain in the next video, because that's also really important.